Hello everybody, welcome to my channel. Today we have a very good problem for you guys called maximum twin sum of a linked list. So this is a very good one, so make sure you pay close attention, right? So any linked list of size n, right, where n is even, if node 0 index of the linked list is known as the twin of the n minus 1 minus I node, right? If I is greater than or equal to 0 and I is less than or equal to n divided by 2 minus 1, right? So this is very confusing, so don't worry about it. I'll explain it to you guys. So let's go through an example. I think for example, if n equal to 4, then node 0 is the twin of node 3, and node 1 is the twin of node 2. These are the only nodes with twins for n equals 4, right? So what they're saying, guys, right, this description is pretty much saying that every node will be given a list, right? And every node will have like some sort of a twin, right? And how do we determine the twins? The twin, it depends on the position that the nodes are, right? The node is whatever, right? So if, for example, right, the first node, right, its twin node is the last node of the list, right? Right? It's because that's the first node from the last, right? And then just like the second node, right? Its twin node is the second node from the last, right? From the end, right? So that's why those are twin nodes, guys, right? So 5 and 1 is one twin, 4 and 2 is another twin, right? You see, it depends on the position that they are, right? You know what I'm saying? So this example is the same thing, right? See this one, its twin node is the version from the end, right? From the last. And the second node, right? Its twin node is the second node from the last, right? That's what we have here. Okay. Yeah. So yeah, it's kind of how we do it. So let's finish the statement, right? So the twin sum, right, is defined as the sum of the node and its twin, right? So this is what the twin sum is, right? The sum of the node and its twin, okay? And given the head of a linked list with even length, return the maximum twin sum of the linked list, right? So we're given this head of a linked list and it's even length, right? And then we need to return the maximum twin sum, right? So for every node, we will need to calculate the twin sum, right? Which is that node and its twin, right? Its corresponding twin, right? We add them up and then we see that's the way we're trying to capture the maximum one, right? So just like this example here, we have here, right? 5 and 1 is 6, and then this other twin sum is 4 plus 2 is 6, right? So they're both equal. So we return 6 as the maximum one that we can get, right? So this is the second example is a little bit better. We have 4 and 3 and 2 plus 2, right? So 4 and 3 is obviously bigger, 7. So that's where we return 7 as the maximum one, right? So we add the twin sum, each node with its twin, right? We get the sum and it's called twin sum, right? That's the result, right? Yeah, this example is pretty straightforward. The first node is and the last node, right, is easily add them up together and you get, this number, right? Pretty simple. So how do we go and solve it, right? We could solve it many different ways, guys, right? So the most straightforward way that I can think of, right, is that we have a linked list, right? We can't easily have access to the last node and just compare, right? Do comparison, right? It doesn't work, right? So that I'm thinking, right, because of that, right, it's not as easy. I'm thinking just we got a linked list, right? Dump all of them into some sort of a list, right? An array, right? And then, right, once we add all the linked list values to a list, right, we can easily have random access, right? So we could easily, have two pointers, right? One at the beginning and one at the end, right? And then, right, we add the sum for each twin, right? And then we work our way inwards, guys, right? So we add 5 plus 1, right? Is 6. We capture that, and then we work our way inward. We move the pointer up. We move the pointer that's at the end, right? Inwards, right? Like I said, we move both the 2 pointers inwards, right? So that's kind of how we would do it, right? It will be pretty straightforward, right? Time complexity will be O of n, pretty good. The space complexity would be O of n as well, right? Not it's pretty good. It's a pretty good way to start. The interviewer might not let you slide with just dumping everything into an array and making it easy, right? No, it would be too easy, right? But yeah, so you can see it wouldn't be too good, right? So we need to do a little bit better. So I'm thinking we need to reduce the time complexity, right? We'll need to introduce some sort of to do some manipulation of pointers, right, guys, right? We've done many problems that involves manipulation of pointers, right? For linked lists, right? So that's kind of what we're gonna have to do if we need to have a chance to reduce the space complexity, right? So we need to kind of do that, right? So how do we do that? How do we do that? That's kind of the ask, right? So let's go through my drawing board, right? We'll kind of brainstorm ideas, right? how we're gonna do it, guys, right? So I took the liberty to just go ahead and this is the exact same linked list that we have here, right? So it's gonna allow me to change it more like easier, right? It's got what I have here. So 5421, right? It's kind of the linked list. So how do we solve these, guys, right? So what I'm thinking, right, is that since we can, because we in a linked list, right, we don't have easy access, random access, right, where we could easily compare the first node with its last node, right? We can easily compare it, guys, right? We can easily do that. So we're gonna have to be more clever, a bit more clever. So how do we be more clever, guys? Or so I'm thinking here is that we're gonna have to, because how do we work our way inwards, guys? How do we start from here and then compare, and then go to this one, right? We know that in a linked list, right? Once we go to a particular node, right, we don't have a pointer to go on to that node, guys, right? Because once we go forward, we can't go back here, guys. That's kind of the thing with linked lists, right? Because there's no pointer, right? We don't have access to our previous node, guys, right? So that's kind of another problem we do. That's why we can't really, even though we had access to the last node, right? How do we work our way, so such that we can do the comparison easily, right? Which is the first node with the last node, right? And then compare the second node with the second node from the last, right? It's not, we can't easily do that, right? Without having that information, guys, right? So we're gonna need to be a little more clever as well, like I said earlier, right? So what we need to do is to maybe, right, because we've done something similar, right? So it's to divide this in half, guys, right? So such that we cut it in half right down the middle, right? So each twin will be on each side, right? One twin will be on each side, right? And then what we could do, right, after we divide it in half, right? And see, we divide it right down the middle, right? We can compare, right? So how do we do that, right? So how do we still have the trouble? I said we end up doing that. We still have the problem of the last node, right? How do we go onto this node after we done adding the sum of this node, those two nodes together, right? Add the sum of those two nodes, right? How do we move forward, right, to our previous node, right? It's not easy, right? So what we're gonna need to do after dividing in half, right? We're gonna need to reverse, guys, right? Reverse the second half, second portion, right? So that it lines up pretty easily with the first first half, guys, right? So you can easily compare, right? So be like this, right? After reversing, right? So it's these 2-1, right? Initially. So after reversing that second half, right? Because we want it to line up perfectly with the first half, right? So that we can do comparison of the twins, right? So you can see how. So now this is the first node from the end, right? So now it's at the beginning, so we could easily have access to that, right? And then we could easily go on to the next node, the second node, right? Which is the second node from the end, right? And that's how we have that second half reversed, right? And then we could traverse it to the second half and compare it with and add it with its twin on the first half, right? So this should be the same length, guys, right? So and we could easily do a one-to-one mapping, right, of the as we traverse, right? No need to keep track of any extra information, right? We could easily just do a linear loop through both, right? List, right? The first half, the second half, add the sums, right? And then capture the maximum one at any given point, right? So it's kind of what it is, right? So we know approaches to find the middle of a linked list, right? We've done many problems in that, right? All those techniques that I'm teaching in this particular video, we've already been through some other videos as well, right? Another problem that's very good for this type of concepts, reordered list. I think this was a pretty good one that you could probably try out as well, right? So I'll probably put a link on the list playlist so you guys could check out, right? We had to do the same thing, divide it in half, and then reverse the second half, right? And so that we could rearrange it, right? So it's kind of the same thing here, but just a different problem, different thing, right? The concept's the same thing, guys, right? So as you can tell, right, we get the sum for each one. So this is 5 plus 1, 6. 5 plus 2, 6, right? So what I was saying, right? How do we find the middle of the element, right? So we would need to the fast and slow pointers, right? This is a very good thing. Fast and slow pointers where we move the one pointer twice as fast and one pointer the same regular speed, right? And then at the end, right, the slow pointer was going to point to the head of the second half, right? And then we reverse it, and then we use the compare. So I'll go into the code. I think it'll make a lot more sense to you guys once I start coding it up, guys, right? Okay. So what we're gonna have here, guys, we're gonna have a list node, right? So we have a slow pointer, which is they're both pointing at the head, right? List node fast, twice as fast, right? Head as well, right? So what I'm gonna have here is while the fast pointer is not null, right? And fast that next, not null. Then move slow, go slow that next, fast, go to fast, that next, right? Because since we're moving twice as fast, right? We do another next as well, right? Okay. So we move twice as fast. So we slow now should be pointing uh at the head, right? You know, you could think about it, you know. So right, so fast, right, would go that next. I'm here, right, and then slow would move to this one, right, and then fast would be that next would be null, and then slow would be pointing to two, right, because it moves slow, right, it moves one step at a time, right, but fast moves twice as fast, guys, right. So that's why slow is gonna be pointing to two, right, you know. And then what we're gonna have, guys, right, is we need to reverse, right? So we could even put that in another function. Right, this node, reversed first list, right? We will take in a list node head, and then we're gonna, you know, pretty much do the reverse problem that we have, guys, right? So prev previous equal to null, right? Don't worry, I'll put a notation so you guys can go check out the reverse problem that we did here, guys, right? So we get reference to the head, right? Whatever node that we're given. While occurs not null, what we're going to do is to capture the next node that it's pointing at, right? You know, let's go to cure that next. So cure that next points to the previous node, right? And the previous node now becomes the current node that we're on, and then the current node moves forward to the original next node that it was pointing to originally, right? Which we overwrote by pointing to null at that particular time, right? So it's just reversing the pointers, guys, right? So and after that we return the head now, right? So prev should be the after reversing it, prev would be the, you know, the last node that was reversed, right? Which means now it's the head, right? But it makes sense to you guys, right? So now we're gonna second half head, right? Will be, so reverse list. We pass in our slow pointer, right? Pass in the slow pointer. Okay, which is the head, which was at the head, right? And reverse that second half, right? So now it becomes it was saying, right, it becomes 1 2, right? Okay, instead of 2 1, that becomes 1 2, right? So now that we have everything that we need so far, right? So what we're gonna do now is to have our mag variable, right? Capture the max, right? Then also have the two pointers, right, to loop through both half, guys, right? You know, like both lists, right? We have, right? You know, so P1 will be in charge of the first half, right? And right, so let's point it to head, right? So the head, this is the original thing that we have here, head. And then now B2 equals to the second half head, right? Which is the second one, right? So now that we have, you know, P1 points to here, P2 points to this one, right? So the reverse, right? And then what we're gonna do, we're gonna, you know, it's a one-to-one mapping, guys, right? You know, as we go through the list, guys, right? We're gonna do while P2 is not null, right? Then we're gonna be inside this loop. So we're gonna do val1 sum is equal to P1 that val plus P2 that val, right? Whatever value they're pointing at. And then max, go to map that max, go to the current max or the sum that we have here, guys, right? And then at the end, we just return the max. Simple as that, right? And then, right, before we do that, we need to move the 2 forward, right? 2 pointers forward, right? Go on to the next one. And then do P2, go to P2, that next. Move on to the next one as well, right? And yeah, just like that, I think we should be good, right? We found the middle, right? And then we reversed the second half, right? So that it could aligned, right? So that we can compare, right? We can do like, the first node with the last node and the second node with the second to last, right? We could go in that sequence, right? Because, in a linked list, in a linked list, right? We can't go back previous node, right? Because we have the pointer to a previous node, right? We don't have that. That's why we needed to reverse that list, right? So that it could align like that, right? So that we could, simulate, right? Going back, right? So after we reverse, we could easily move in the other direction, right? Because we reversed the half, right? That's kind of what we did. And when we did that, we just, add each twin, right? We calculate for each twin, we calculate the sum, right? And then, right, we capture the maximum one at any given point, guys, right? So let's check if we're good, man. Okay, looks like we're all right. Let's press submit. Awesome, guys. We're going to pass all these test cases, guys. If you guys found value, you guys understood the thought process in the comment section. If you're new, be sure to subscribe because we'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next video.